and alkynes. Alkenes contain a C double bond C, alkynes a triple bond. Anytime I have these things present, I have the possibility for these molecules to undergo addition reactions. One of those can break, or two of those can break, and then other things can be added in its place. Or one of those, and then I can add on another thing. Things that I can add in, I could add in an OH, an H, F, Cl, Br, an I, a Br2 could be like how these could form a Cl2, F2, I2. Water could be used to get these guys in, lots of different things. So let's take a look at some examples now. I've got this alkene, I've got hydrogen gas, I need these as a catalyst. I'm going to add in H2s, this guy's going to get broken, I'm going to get propane in the end. Yes. I'm going to add in a Br, that's a 2, that's going to get broken. One Br is coming on here, one Br is coming on here. So there's my carbon chain. I'm going to get a Br added onto both, and then I get the hydrogens that I started with. Next guy, HBr. Now here I was giving a Br on both, so it didn't matter where these things went, because I'm putting in a Br, each carbon's getting a Br, but here one's going to get an H or one's going to get a Br. So my possible outcomes are the H going on here and the Br on here, or the other way around with the Br going on here and the H going on here with the original carbons. Which one? Do I get this guy, or do I get this guy, or do I get some of both being made? And the answer comes from Markovnikov's rule. When a compound like HY is added to an unsymmetrical alkene, the hydrogen becomes attached to the carbon with the most hydrogens attached to it already. And there's a little phrase, the rich get richer. So the H is going to the carbon with the most H's. So let's take a look here. I'm going to get a different color. Two choices. It's this carbon or this carbon. This carbon right here has one H attached to it. This carbon has two H's attached to it. One here, one here. True? So where is the H going to go here? It's going to go to the carbon with the most H's. So the H will be going on this guy, and the Br will be going on this guy, and that makes this guy the proper answer. You will only ever get this guy, never get this guy. Markovnikov's rule is 100%, rich get richer. So here's another example. I'm going to be adding in an H to one of the carbons and OH to the other. Where's the H going to go? It's going to go to the carbon that has the most H's. This carbon has one H, this carbon has two H's. Looks like this carbon's getting the H, this carbon's getting the OH. So I'm going to get my 3-carbon chain. This guy's getting the OH, this guy's getting the H, and then there's some other H's attached around. Here's a triple bond question. Yes. I break this guy. Now here it doesn't matter. Well, okay, no, my apologies. It does matter. The H is going to go to the carbon with the most H's. I'll get my red out. So I'm looking at this guy or this guy. This guy has no carbons. Or sorry, my apologies. This guy has no hydrogens. This guy has one hydrogen. So the H is going to go on here, and the F is going to go on here. That's an H, believe it or not. So I'm going to get this happening. H and H, yes. And then if I was to add in another one, on reacting this, I am going to get the H is going to again go to this guy because there's 2 here, none here. So I'm going to get C attached to a C, attached to a C, H, F, F, H, H. Okay. Now combustion. We'll say that it's going to be complete combustion. I would get CO2 plus H2O. And I could go about balancing this, and I might as well right now. So this is C2H4 plus O2 gives those guys, just so it's better, easier for me. So I definitely have 2 carbons here. I need 2 carbons here. I have 2 hydrogens. I need 4. I'm going to put a 2 here. That gives me 4, 5, 6 O's. 6 O's means I need a 3 right here, and then that guy is done. Check. And that is our look at the reactions of alkenes and alkynes. Key point, Markovnikov's rule. Hydrogen goes to the carbon with the most hydrogens. A little saying to remember here.